Good morning. Today I'll be presenting on genetic and phenotypic relationships among yields of milk, fat, and protein in the first 3 lactations of South African Guernsey cattle. The current study was conducted with the Agricultural Research Council and the Tshwane University of Technology. Improved herd profitability is a major goal in dairy breeding, which includes improvement of milk production and retaining the best heifers. In order to achieve such improvement, all economically important traits should be genetically evaluated on a regular basis. Milk, fat, and protein yield are among the most economically important traits in dairy cattle. Therefore, this necessitates accurate estimation of breeding values for these traits. The Guernsey is one of the major dairy breeds in South Africa. They are noted for high butterfat, high protein quality, docility, high feed conversion efficiency, early reproductive maturity, and good calving performance. Due to all these characteristics, the Guernsey presents an opportunity for use in smallholder farming sectors in South Africa. Genetic parameters of production traits have been estimated previously for South African Guernsey cattle. However, it is important to re-estimate them on a regular basis as they are subject to change over time. The last estimate for milk production traits of South African Guernsey cattle were computed over 10 years ago. Hence, new estimates are now overdue. It is also important to consistently revise genetic evaluation models in order to implement improvement in their prediction ability. This leads us to our aim being to estimate the genetic and phenotypic correlations among milk, fat, and protein yield in the first 3 lactations of South African Guernsey cattle. Lactation records were obtained from integers on South African Guernsey herds participating in the National Milk Recording Scheme during the period 1980 to 2013. The original dataset consisted of about 65,000 records, where head year season was defined as the contemporary group. 2 seasons were defined in the current study, being summer and winter. The age range in months was defined as follows: 24 to 40 months being the first parity, 30 to 55 months being the second parity, and 40 to 70 months being the third parity. The following records were omitted during data editing. Records with missing results for milk, fat, and protein yield, head identification number, birth and calving date. Outliers for 305-day lactation yields of milk, fat, and protein, contemporary groups with less than 8 animal records together with those with less than 3 sires. Sires with less than 3 daughters in a contemporary group, and sires and dams with unknown identification number and birth dates. The final dataset consisted of 305-day lactation records from about 16,000 cows in 639 herds from animals participating in the National Dairy Animal Recording Improvement Scheme during the period 1980 to 2013. The pedigree data consisted of about 19,000 animals from 705 sires and 9,706 dams. The descriptive statistics of the traits were computed using prog-means procedure of SAS. The genetic and phenotypic parameters were estimated by the RAML procedure using the AS-RAML software. Environmental effects affecting the traits were determined by prog-GML procedure of SAS. Environmental factors included in the model were head year season of calving and the linear and quadratic effects of age at calving. A multi-trait animal model was used where yields in different parities were treated as different traits. Y was the vector of observations, X incidence matrix relating fixed effects to observations, B. Vector of fixed effects influencing milk, fat, and protein yield. Z. Incidence of metrics relating random animal additive genetic effects to observations. Mu. Vector of animal additive genetic effects. And E. Vector of random residual effects. Table 1 shows the descriptive statistics for yields of milk, fat, and protein in the first 3 parities of South African Guernsey cattle. The respective coefficients of variation for the production traits were comparable within all parities. Table 2 shows environmental factors influencing milk production traits in parity 1, 2, and 3. Headier season was highly significant in all 3 parities for milk, butterfat, and protein yield. Aged calving had no significant effect on milk and protein yield in the second parity, but was highly significant in the first and third parity for all 3 traits. The quadratic effect of aged calving was highly significant in the first and third parity, but was not significant for milk, butterfat, and protein in the second parity. Table 3 shows the estimates of genetic and phenotypic correlations between milk, butterfat, and protein yield within parities 1, 2, and 3. All the correlations between the production traits were high and positive. In general, the correlations were highest between milk and protein yield and lowest between milk and butterfat yield. Table 4 shows the genetic and phenotypic correlation among different parities for milk, butterfat, and protein yield. Correlations were higher between adjacent parities compared to non-adjacent parities, where 0.91 was the highest genetic correlation and 0.41 was the lowest genetic correlation. 0.50 was the highest phenotypic correlation and 0.13 was the lowest phenotypic correlation. Table 5 shows the genetic and phenotypic correlations among milk, butterfat, and protein yield estimated across parities. All the correlations were positive and high, with phenotypic correlations being higher compared to genetic correlations. Variation in milk, butterfat, and protein yield was influenced by headier season, parity, and the linear and quadratic effects of aged calving. The high genetic correlation among the production traits within different lactations indicate that selection for one of the traits is expected to result in a correlated increase in the genetic merit for the other traits. Genetic correlations among different parities for the same trait were lower, implying that production in different lactations cannot be considered as the same trait. In conclusion, the high degree of association among milk production traits of South African Guernsey cattle provides a favorable basis for multiple trait genetic valuation for these traits and their inclusion in the breeding objective. Thank you for your attention.